Great.
Yep, go ahead.
Okay. Hello, everyone. I'm going to walk you all through this recently published paper in the special edition of CA2 and Hippocampus. So I'm going to talk about how the alteration of hippocampal CA2 plasticity comes about as a result of juvenile stress. So I did this project a couple of years back in 2018, 2019-ish, when I was doing my PhD under Dr. Saji Kumar in National University of Singapore in NUS. I'm currently a postdoc at Columbia University in New York. Since the central theme of this project is stress, I'm going to start off by emphasizing some of the key terms that we already know. A stressor is anything in the outside world that knocks you out of homeostatic balance, and the stress response is what our body does to establish homeostasis. Just give me a moment. I'm going to push this panel down so that I can see my own slides a little clearly. Sorry about that. Okay. Yeah. So just to give you a quick introduction about how this project came about, by the time Saji and I discussed about doing this project, I had already detailedly wrapped up my experiments on the effect of juvenile stress in CA1 region. And we had a fair idea of how the synaptic competition and inhibitory metaplasticity happens because of juvenile stress in the area CA1. And about the same time, one of my senior, Ananya, so she published this paper on the effect of substance P and how it induces plasticity in area CA2. And during the ripe phase of this conversation between Saji and I, and we plan to extend this project, the implication of stress in CA1. We wanted to see as a next step, like, should we look at amygdala, should we look at CA2? A lot of regions came to our mind. But about the same time, Siegelbaum's lab came up with this paper back in 2018 when we were wrapping up this project, showing the link between dorsal CA1, ventral CA2, CA1 and CA2. And we thought it would be silly not to look at the effect of juvenile stress in CA2. So we set about looking at some of the behavioral experiments and slice electrophysiology experiments in CA2. So first, I will walk you through the behavioral experiments, but our objectives were super straightforward: to understand juvenile stress effects in CA2, both at the systems and cellular level, and to get a better understanding of markers if possible, and study associative memory mechanisms. So the behavior methodology, the first step is the stress paradigm, where the animals go through a 3-day consecutive stress paradigm. It's a well-established stress paradigm by Tsuri Levin at the Weizmann Institute and Professor Galrich Levin at the University of Haifa in Israel. So this model has been well-established since 2006, about 2007. So the first day involves post-swim test, about 3 trials, each 15 minutes in 22 degrees Celsius water temperature. And the second day, the immediate consecutive day, happens to be the elevated platform for about 30 minutes. And the third day is the confined box for about 4 hours in the dim lit room, where the animal cannot move their arms or limbs. And once this happens, once the stress paradigm is complete, they're sent back to the home cage. We wait until the animal gets to the adult stage for about 5 to 7 weeks old. And then I test the social recognition test that Professor Bashir just introduced. So we adapted this social recognition test, where the first day it involves a sociability test with an empty cup and a never before met novel animal, where the subject rat is introduced between these 2 arenas. And then on the subsequent days, where I tested immediately post 24 hours of the first day and then post 7 days as well, I do the social interaction test between the familiar and never before met stranger rat. So just as a sanity check, although this is a well-established stress model, just to establish that there is indeed a significant increase in the stress levels between the healthy and the juvenile stress animals, I measured corticosterone levels, and there was a significant increase in cork levels in the adult rats, in these 5 to 7 week old rats. So these rats were then subjected to the sociability test. So looking at how they interact between the empty cup and a never before met novel candidate, we see that there is a significant increase in the interaction time and in terms of frequency as well for the healthy animals, which tend to prefer the novel candidates. But in the case of the stressed rats, they prefer to spend more time with the empty cups. Okay. So this I measured post 24 hours and post 7 days as well. And we see a similar trend where the control rat tends to prefer to spend more time with the novel candidate, both in terms of frequency of visits as well as interaction time. And this trend seems to repeat in the post 7 days as well. And it's interesting that they seem to remember for that many days, both in terms of short-term memory as well as a long-term memory. So they don't necessarily, the juvenile stress rats, they don't necessarily seem to have impairments in social memory per se. They seem to remember because at least they know who to avoid. So in terms of latency to first, which tells us how quickly they initiate contact with the empty or the stranger rats, we see that the control rat tends to prefer or initiate contact much more quickly with the novel candidate, as opposed to the stress rats preferring to initiate contact much sooner for the empty cup as opposed to the novel candidate. The same is seen for post 24 and post 7 days as well. So the same is seen in the difference in scores, where there is a higher propensity for the healthy or the control rats wanting to spend more time or wanting to interact more with the novel candidates, as opposed to the juvenile stressed rats. So we see that they very actively seem to avoid novel interactions. So next, moving on to the slice electrophysiology experiments. So these male Wistar rats at about 5 to 7 week old. So I take out the slices that are 400 micrometer thickness, and then we have a recording electrode and 2 stimulating electrode, one for control and one for the stimulation, or sometimes one at the shaft-collateral fibers and another at the entorhinal cortical synapses. So if we look at it, this has already been shown by a couple of labs where we know that the shaft-collateral synapses at CA2 is resistant to LTP, but the entorhinal cortical synapses show LTP. But in the case of juvenile stress, it's intriguingly contrary to our expectations. We saw induction in both the shaft-collateral synapses as well as the entorhinal cortical synapses, but they failed to maintain the late phase LTP. And we wanted to try and exogenously bath apply substance P because Ananya in our previous, one of our seniors who already established the study with substance P, and we know that substance P is involved in conditions of stress and trauma and pain mechanisms and anxiety related studies. So substance P is endogenously produced, but in the case of juvenile stress, we weren't sure if it would be released endogenously as well, because there are direct innervations of supramammillary fibers into the CA2 region. So we were kind of hoping that there would be an interesting result to this. So when you apply substance P exogenously, the bath applied substance P in the healthy control slices show chemically induced LTP, a slow onset potentiation of late LTP in both shaft-collateral synapses as well as the entorhinal cortical synapses. But in the case of juvenile stress, there is absolutely no LTP in both entorhinal cortical synapses as well as the shaft-collateral synapses, which we thought was very interesting. So I suppose there's probably an occlusion of LTP that is happening because of endogenously produced substance P, possibly because of the juvenile stress. And it's also interesting because of despite the fast turnover of substance P that happens endogenously. This seems to last for a really long time, even quite until the adulthood. So yeah. So I want to leave you with the summary that the rats that are subjected to juvenile stress resist LTP in the CA2 region, both in the entorhinal cortical synapses and shaft collateral synapses. And in the case of substance P does not seem to induce any LTP. Substance P does not seem to induce any LTP. And in the case of rats that are subjected to juvenile stress, in the case of behavioral experiments, it is interesting that they actively avoid novelty and any kind of novel exploration with their conspecifics, as opposed to an empty cup. So the juvenile stress rats, since they actively seem to avoid novelty that appears to be regulated by hippocampal area CA2. So about the time that I wrapped up this project, as a next step, we also wanted to look at the mechanisms in the CA2 and possibly probe NK1 receptors, but I could not continue this project because I had to start my postdoc here. And right now I'm doing my postdoc with Abid Husseini in Columbia University. I'm looking at the dysfunction of LEC in Alzheimer's disease, looking at the object and trace cell impairments. So I'd like to thank both my current prof and my previous PI, Dr. Saji Kumar, and all my previous lab members, and everybody who collaborated with me and all my rats. Yes, thank you.